Question 2, Part D. The diagram shows the locus of point Z in the complex plane such that arg of Z minus 3 minus arg of Z plus 1 equals pi over 3. This locus is part of a circle. The angle between the lines from -1 to Z and from 3 to Z is theta as shown. Copy this diagram into your writing booklet. Part 1. Explain why theta equals pi over 3. Consider the triangle inscribed in the circle. I'm going to let angle alpha equal arg of Z minus 3 and angle beta equal arg of Z plus 1. Now angle alpha, being an exterior angle, is equal to the sum of the opposite interior angles. That is, alpha equals beta plus theta. Now rearranging this equation, we get alpha minus beta is equal to theta, which is equal to pi over 3. Part 2. Find the center of the circle. I've labelled the center of the circle with the letter C. Now the x-coordinate of the center of the circle is the midpoint between -1 and 3. So -1 plus 3 in brackets divided by 2 is equal to 1. Now to find the y-coordinate of C, we need to consider the altitude or the vertical height of this isosceles triangle. Now it's isosceles because the interval from the center of the circle to the circumference is equal to the radius of the circle. So we have two radii, here and here. Also note that the angle at the center of the circle is twice the angle at the circumference subtended by the same arc. So what I've done is to extract this isosceles triangle, noting that the angle at the center here is 2 pi over 3. So here's the isosceles triangle. We know that the base of the isosceles triangle is 4 units from -1 to 3. And if I divide this isosceles triangle in half, we form two congruent right angle triangles. And the angle, or the half angle at the center, is pi over 3. So pi over 3 plus pi over 3 gives us 2 pi over 3. So I'm going to consider one of the right angle triangles because we want to find the height of this right angle triangle, which is the dashed line here. And I've noted that here, the y-coordinate of the center corresponds to the altitude of the triangle shown, which is this triangle here. So considering one of the right angle triangles, we want the length of the dashed line, which is the altitude of the triangle, so we can use the tan ratio. So tan of pi over 3 is equal to opposite over adjacent, so 2 divided by the altitude. Rearranging this equation to make the altitude the subject, we get altitude is equal to 2 divided by tan of pi over 3, which is equal to 2 divided by root 3, or 2 over root 3. So putting that all together, the center of the circle has coordinates 1, 2 over root 3.